Okay, so as I was saying about, talking about in the last video about power, we can write it in such a form that power is equal to the force dotted into the velocity. So we're going to go ahead and apply that to this last example, 7.12. It states how much power must an automobile engine expend to move a 1,200 kilogram car up a 15% grade at 90 kilometers per hour. Assume that 25% of this power is dissipated, overcoming air resistance and friction. So the first, whoops, I need my pen out. First thing we want to do is set up our equation. So again, power is going to be force dotted into velocity. Okay. Our power is 25% of this power is dissipated, so we only have 75% of the power. Okay. Now our force is going to be is in our y direction, so we have x and y. Okay, so we have mg, and we just want our y component here. So let's see. Actually, that is coming in with our velocity. So our velocity, we'll see. Okay, so let's see. This will be j hat. Sorry about that. Our velocity is going to be in our y direction as well. So we have, if we say that this is our angle, our 15% grade, we have opposite over hypotenuse. So it will be v sub y, I should say, is equal to v sine theta. Okay, so our v is our 90 kilometers per hour. Our theta is based on this 15% grade. Now we can't just put in like 15 degrees because that's not what the 15% grade means. So when it says 15% grade, it means that the tangent of this theta, this angle here, is equal to 15%. Okay? Or we can say theta is equal to tan inverse of 0.15. Okay, and notice that this is going to be in radians. Okay? So our velocity, our y component of velocity, is 90 kilometers per hour times sine of tan inverse of 0.15. Okay. All right. So we can plug all of this in, and we know that we're just looking at the y component, so we can say mg times v sine of tan inverse, say vy, of 0.15. Okay, so this is our equation. And again, we are looking for the power, and power is typically in joules per second. Okay, so we will need to change our velocity. Oh, this is just v. Sorry about that. Our velocity in terms of meters per second. So let's go ahead and do that up here. Velocity equals 90 kilometers per hour. There are 1,000 meters in 1 kilometer, and in 1 hour there are 3,600 seconds. Okay, so we can go ahead and calculate that. We have 90 times 1,000 divided by 3600. So we get that the velocity is 25 meters per second. Okay, so we will get our equation and say P is equal to our mass, which our mass is 1200 kilograms. Multiply that by G, which is 9.8 meters per second squared. Multiply it by our velocity, which we just found to be 25 meters per second. And multiply that by sine of tan inverse of 0.15. And divide that all by 0.75. Okay, so now we have kilograms, we have meters squared over seconds cubed, which is good. That means we are in joules per second, so our units are correct. So let's go ahead and plug this into our calculator. Divided by 0.75. And we get that the power is 58,000. Let's see how many units. Yeah, so 58,000 watts. Or we can say 58 kilowatts. Okay? So this is the power output of that vehicle traveling at 25 meters per second, or 90 kilometers per hour, up that 15% grade. All right? So that is the end of this series here, of this PowerPoint. And so I will see you in the next video. Email me if you have any questions.